Hello everyone, welcome back to my channel. In this video, we will be looking at the activities and features formed along plate margins. The Earth is divided into three main layers: the core, the mantle, and the crust. The core itself is subdivided into the solid inner core and the liquid outer core. Above the core is the mantle, which is broadly divided into the upper and lower mantle. And the crust is divided into the continental crust and the oceanic crust. The upper mantle may be subdivided into the lithosphere and the asthenosphere. The asthenosphere has the ability to move slowly. It is ductile in nature. And within the asthenosphere, there are convection currents formed due to the unequal heating within that layer. The lithosphere is the combination of the rigid part of the upper mantle along with the crust. Now, for us to appreciate what goes on at plate margins, we need to also understand the difference between the oceanic and continental crust. So the oceanic crust is the type of crust that forms the ocean floor, while the continental crust basically forms the continent. The oceanic crust is thinner than the continental crust, but it is denser. It is made up of silica and magnesium and has the ability to sink into the mantle. Because of this, the rocks are constantly being recycled, and so the rocks that make up the oceanic crust are younger. The continental crust, on the other hand, is thicker but less dense than the oceanic crust. It is not dense enough to sink into the mantle, being made of minerals such as silica and aluminum. Because of this, the rocks are not recycled, and so the rocks are older. Now, the lithosphere is broken into smaller segments called plates. There are 7 major plates. These include the Eurasian plate, the African plate, Indo-Australian plate, the Pacific plate, North American and South American plates, and the Antarctic plate. Besides these, there are some minor plates also. Some of these minor plates include Arabian plate, Philippine plate, Cocos plate, Nazca plate, Caribbean plate, and Scotia plate. The plates can be completely oceanic, They may consist of oceanic as well as continental crust. Nazca Plate, for example, is an oceanic plate consisting of oceanic crust alone. The African plate consists of both oceanic crust and continental crust. Now, where the plates meet, they form plate margins. Now, there are 3 plate margins identified based on their movements as well as the features that result from those movements. At a convergent plate margin, the plates are moving towards each other, and usually plates will be destroyed at this plate margin. Therefore, this plate is also called destructive plate margin. The divergent plate margin is where the plates are moving away from each other, causing magma from the asthenosphere to rise to the surface and form new plates. This boundary is therefore also called the constructive plate margin. At a transform plate margin, the plates are sliding past each other. Plate is neither formed nor destroyed, and so this is also called a passive plate margin. When 2 plates made up of continental crust meet at a convergent plate margin, the plates are not heavy enough to sink into the mantle, so they might fold on top of each other and push upwards, cause the rocks above them to push upwards, and this will give rise to fold mountains. These fold mountains that are formed in this way are not usually volcanic in nature. An example of a fold mountain formed this way is the Himalayas fold mountain range. The Himalayas fold mountains were formed from the collision of the Eurasian and the Indo-Australian plates. Both plates are made up of a continental crust. This is the highest fold mountain range on the earth. When an oceanic crust and a continental crust meet at a convergent plate margin, compressive force cause the rocks in the continental crust to be pushed upwards and fold mountains are formed. The oceanic crust, being of a high density, will sink beneath the continental crust. At the point where it sinks beneath the continental crust, a long and narrow depression will be formed called a deep sea trench. When the crust reaches in the mantle, it will melt because of the higher temperature and also because it would have carried down some amount of water that will increase the amount of melting. The magma that results from this will be lighter than the surrounding rocks and therefore will rise to the surface to form a series of volcanoes. This series of volcanoes is called a volcanic arc. So fold mountains formed in this way are volcanic in nature. They are also located in coastal areas. Now, an example of a fold mountain that is formed this way is the Andes Fold Mountains, which is formed where the Nazca Plate and the South American Plate meet. The Nazca Plate is an oceanic plate, while the South American Plate is a continental plate. The Andes Fold Mountains is the longest fold mountain range on the Earth. An example of a deep sea trench is the Mariana Trench, formed where the Pacific Plate, which is oceanic, sinks beneath the Philippine Plate, which is continental. This is the deepest deep sea trench and also the deepest part of the ocean floor. Now, a third situation may exist where two oceanic crusts meet. Remember that oceanic crust is heavy enough to sink into the mantle. But when two oceanic crusts meet, both plates will not sink into the mantle. The heavier of the two will sink. The heavier one is usually the older plate. As the plates get older, they usually get colder and therefore will become denser. So the heavier plate will sink beneath the less dense plate, and the point at which it sinks, a deep sea trench will be formed. The plate, after sinking into the mantle, will melt to form magma, and the magma being lighter than the surrounding material will rise to the surface to form a series of volcanic islands called an island arc. So notice the difference. When an oceanic and continental plate meet, the series of volcanoes that form on the continent or on the continental crust is called a volcanic arc. However, where two oceanic crusts meet, the series of volcanic islands is called an island arc. It's important for you to understand the difference. Now, a good example of an island arc formed in this way is the Eastern Caribbean island arc. This island arc was formed as a result of the North American plate and the Caribbean plate meeting. At a divergent plate boundary where the plates are moving past each other, some spectacular features may also be formed. Divergence often occur in oceanic plates, but can also occur in continental plates. Where divergence occur in oceanic plates, a long rift will be created in the plate, and magma from the asthenosphere will rise to fill in that gap. As the magma rises, the crust will expand, and so at that rift zone, the land will be higher than the surrounding land. Over time, that area where the new crust was formed will move away from that center due to further divergence occurring. And as it moves away, it gets older and colder and will sink down a bit. So as a result of this, a ridge is created beneath the sea. Now, this feature is the mid-oceanic ridge. In some mid-oceanic ridges, there is a rift valley at its center. At others, there is no rift valley. Now, where the ridge, because the ridge does not have the same height throughout, at certain points, the ridge may be high enough to rise above the level of the sea. This will create a volcanic island. An example of this is Iceland. So this is the Mid-Atlantic Ridge, and the Mid-Atlantic Ridge is the longest chain of mountains on the globe. Let's not confuse it with the Andes. The Andes is the longest fold mountain range, but the Mid-Atlantic Ridge is the longest chain of mountains. But most of this mountain is beneath the sea. So this video clip shows parts of Iceland where the Mid-Atlantic Ridge rises above the sea. When divergence occurs in continental crust, magma may be intruded into spaces that are created as a result of the plates being pulled apart. So this may create dikes. As the plates continue to be pulled apart, some fault lines may be created. Over time, the blocks of rocks around these fault lines may begin to move up and down, and oftentimes the central block between surrounding blocks might move downwards to form a rift valley. Sometimes this rift valley may be filled in with water to create lakes. Now, an example of this feature is the East African Rift System. The Red Sea formed between the African plate and the Arabian plate is another example of divergence within a continental plate, but it represents a later stage than the East African rift system. The final plate margin is the transform plate margin, where the plates slide past each other. As the plates move against each other, earthquakes may be created, but no major landforms usually develop at this plate margin. One of the best examples of transform plate margin is the San Andreas Fault in California, USA. Now let's look at a tectonic map. As we can see, the arrows indicate how the plates are moving. At points, the plates are moving away from each other. At other points, the plates are colliding. So for example, where the Nazca plate is moving to the east and the South American plate is moving to the west, they converge. We also see where the Indo-Australian plate moves towards the Eurasian plate and another convergent plate margin is created right there. We can also see the North American and South American plates generally moving to the west, while the Eurasian and African plates are generally moving towards the east, and so a rift zone is created there. And this is the location of the Mid-Atlantic Ridge. Where the Mid-Atlantic Ridge rises above sea level, we can see Iceland in the northern section of the map. Now here is another tectonic map showing the Caribbean and the adjacent plates. Notice that the Caribbean is generally moving towards the east, and therefore at the eastern edge of the Caribbean plate, it is converging with the North American plate. At the northern part of the Caribbean plate, where the North American plate is moving to the west and the Caribbean plate is moving to the east, a transform plate margin is created there. Now, most tectonic activities and major landforms are created at plate margins. The center of the plates are usually inactive and usually are areas of low relief, except for the center of the African plate. But if we look at this map, it is showing the margins that generally surround the Pacific plate. This is the main area on the globe where most of the earthquake activities and the volcanic activities occur. This is called the Pacific Ring of Fire. Now, there's also something I want to show you. Notice that in the center of this plate, we are also seeing that activity is occurring there. Now, the reason for the activity occurring within the center of the Pacific plate is that that area lies above a mantle plume or a hot spot in the mantle. Now, the mantle plume causes melting and thinning of the crust above it, and this results in volcanic activity and the formation of shield volcanoes. Now remember that the plate itself is still moving. So with time, the volcano that is formed over the hotspot will move away from the hotspot because of the plate movement, and a new volcano will be formed above the hotspot. As the plate continues to move, the volcano will now move away and a new volcano will be formed over the hotspot, which is fixed in position. And therefore, over time, a volcanic island arc is created. This island arc is not formed in the same way that an island arc forms when two oceanic plates meet, of course. A good example of this situation is the Hawaiian Islands, formed in the Pacific Ocean and formed within the Pacific plate. Okay, thank you very much for watching. I hope you enjoyed. I hope you learned something from this video. Don't forget to like, to share, and to subscribe.